Hi, I'm Greg Perkins, the instructor for this class. These online notes are an abbreviated version of what you would find in the textbook. I'm basically going to be covering the most important ideas to keep these videos short and yet definitely relevant. So you'll still need to read the book and do your homework, but this will cover the most important ideas. And now on to section 1.2. So this section, it has a few definitions in it, but most of it is just logical or critical thinking. A couple of the definitions: population, that's the whole group that's going to be studied. So for example, if it was the United States, that would be some 325 million people. Of course, going out and interviewing 325 million people is too much work, so you might say, well, I'm going to choose 1,000 people. Whatever the subgroup is, that subgroup is called a sample. Later sections will cover specifically how do you get the sample, but that's the general definition. Some subgroup is the sample. When you then gather information from your sample, that is a statistic. If it was information about the whole population, it's called a parameter. What's nice is the two statistic and sample both start with S. Population and parameter both start with P. That's how I remember it. So for example, you could get the person's hair color, their age, weight, etc. That's the type of statistics that you can gather. So an important idea in this section is that people should not be able to choose themselves to be in a study. So if you're trying to figure out, who's going to, are you going to vote for candidate A or B? Well, you need to go out and talk to those 1,000 people and ask each and every one of them, who are you going to vote for, candidate A or candidate B? You shouldn't just have them choose themselves. So for example, if they say yes or no to a certain candidate and you just have them, oh excuse me, this is a movie, you have them text yes or no, well the only people that are going to do that are those that feel very strongly. So you're going to get a biased sample. So here's an example of just using logical thinking or thinking critically. 56% of Catholics say they would be in favor of having female priests. In case you didn't know, the Catholic Church does not allow female priests at this time. Anyway, what's wrong with this statement? So you could just think about, well, Catholic, there are millions of Catholics throughout the world. So does this mean 50% of them throughout the world, or is that just in the United States? If you went to Guatemala, the percentage might be much different than if you went to Florida. So does this graph seem reliable? So this is basically people were asked, do you approve of the job that Congress is doing? And this seems sort of strange, this big uptick right here from 19% to 39% back in 2009. And then it just sort of dwindles down over the years. They cite that this is a Gallup poll. So I actually took this from the Gallup website. And Gallup is a reliable source. So I would say, for the most part, I don't really see anything wrong with this. Other than this seems strange right here, that it would jump from 19% approval rating up to 39%. The rest of it seems pretty believable. So just categorize this as possible, likely, or impossible. It will rain tomorrow. Well, it's possible. Living in California, it's pretty unlikely, but it is possible that it could rain tomorrow. Justin Bieber will be the next president, will be the president of the United States someday. Well, since he's not a politician, I doubt it. Also, I'm not sure, but I think Justin Bieber is Canadian. If he's Canadian, then he can't be president of the United States. Has to be a citizen of the United States. But just for political reasons, I don't think people are going to elect Justin Bieber. Now, if I say 80% of this class is going to pass with a C or better, if at another point I say it's 80.4% of my previous students had passed with a C or better, which of the two is more convincing? Well, when people use numbers like this, 80.4, it sounds like they're being more accurate. Whether they are or not, I'm not sure, but it just sounds more accurate. And also I'm saying This has happened with my previous students, so then I'm basing it off of some past history. Where the first statement, I'm just saying 80% of the class will pass, as if I could predict the future. Well, this second statement seems more believable. There's a little more definition, and it's based on previous history. So this is Apple stock price. This is Apple stock price. Why? Stay there. Okay, so it went from $400 at one point to $550. So what's wrong with this little graph? Well, hold on. The problem with the graph is this bar compared to this bigger bar in January. The bigger bar looks like it's 3 times bigger than this little bar. So if that was true, it would go from 400, 3 times bigger would be 1,200. And it didn't triple in price, but since this is not drawn to scale, then it is deceiving. Suppose you call someone's house. Well, that's already a problem because not a lot of people have landlines anymore. And you ask them how much they pay for gas. Well, the biggest problem is that you call their house, and most people don't have landlines. Those that do are usually older Americans that have had the landlines in their house for the last 30 years or something like that. So you would only be getting a small segment, a very specialized small segment of the population. It would be much better to just walk around the street and ask people rather than calling their house. So, is a score of 80 above the average of these? Well, the problem with this is average is actually a vague term. You'll see in a section later on, there are actually different types of average. There's the mean, median, mode, mid-range. They're all different types of averages. So one of those averages is called the median, and that means the middle score. So you just find the one in the middle, 78, and you could say 78 is the average. So is 80 above that? Yeah, in that case it is. We could also add the numbers together and divide by 5, and that's a different type of average. So the main problem with this is the word average is sort of vague. Now just a little bit of fractions, percents, and decimals. So this is just a quick example, 2/5. If you divide that on the calculator, you'll find out it's equal to 0.40. That's the same as 40%. So to change a decimal to a percent, just move the decimal over by 2, 40%. And then from 88%, so what you could do is percent literally means per 100. So right here with 88%, you could write it as 88 over 100, so percent. And then you reduce that, so divide by 4 and divide by 4, 22 out of 25. And then complete this little table right here. So 0.9, if you multiply by 100, this would be 90, so this would be 90%. This number right here could also be read as 9/10, so you could put right here 9 over 10 for 9/10. 24%, you move the decimal to the left, and the decimal part would be 0.24. The fraction, 24 over 100, and then reduce that. And then for a half, the decimal would be 0.5, and the percent is 50%. And then for 2/3, well, the directions here didn't say how many decimal places I'm supposed to use. If you use 2 decimal places, then it's going to be a 0.67, and then that would be 67%. Throughout most of the class, I would say use 3 decimal places. So this would be 2/3 would be 0.667, and the percent would be 66.7%.